See if it'll stay there. Keep messing with it, Jeff. Alright.
Why is it so dark? Somebody flip both of those switches. Flip them up.
Yeah, hey, look at that. Let there be light.
Alright, let me see what you guys know. How many people in here currently are left-handed? I'm not, so I won't raise my hand. 1, 2, 3 people? Okay. There they are. No, sorry. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 31. So there's 31 people in here, and there are 3 people that are left-handed. So if I blindfolded somebody, spun them around, and they went wandering around the room and grabbed somebody, what is the probability that they grab a left-handed person?
3 out of 1.
Yeah, they have 3 chances to grab somebody who matches what they're looking for out of 31 total things that could happen. All right. Let me stop there for a second. That's the basic idea of probability. Is the top is going to be the number of things that match what you're looking for. That's the total chances you have of finding that thing out of all the other things you could find instead. Or including them, which is out of everybody. All right, so the bottom is always everything that could happen, and the top is the number of those that match what you're looking for. So normally we kind of know that. In fact, you might realize if I said, what's the percentage of people in this class that's left-handed, it would still be 3 out of 31, right? So percentage, really on a very basic level, is the same thing as probability. Now percentages, would 120% make sense? Yes. I can make 120% more money this year than last year. It's more than double, right? 100% more would be double, 120% more would be more than double. That's fine. But I can't say the probability it's going to rain today is 120% because it's really big rain. What the hell would that mean? Right? I mean, does that make sense? We all know this. So on a very basic level of what percentage is, they're the same thing. Probability and percentage. And this symbol, you might remember this notation from algebra. Oh, shit. Don't freak out. We're not going to suddenly start doing this, right? But it's how to read this comes from this. How do you read this? Who remembers?
F of X.
F of X. So this is probability of left-handed person. So see, the input for this is kind of like an event. So the input for probability is the question, what's the probability of this thing? It's some kind of an event. And an event can be a left-handed person. Right, so when I say the word event, we normally think something televised, so it's not going to be, oh my God, it's a left-handed person. But an event is just something that could happen. Right? So if I roll a die, all my Dungeons and Dragons people, it's a 6-sided die, right? What's the probability that I roll an odd number?
1/2.
Yeah, so let's build it up. So how many sides are there? 6. So out of 6 sides that could show, 3 of them are odd, right? 1, 3, 5. And of course that reduces down to 1/2. Cool. I like it. I'm going to let this sink in a little bit. I want to get a feel if everybody's kind of like starting at the same place. Because we are going to get a little bit more complicated than this. Okay. So let me try to jump into this. Let me try to jump right into something. See what you guys think. And you're all like, just do it, man. So say I talk to a bunch of men and women and I ask them some question. So you can just imagine what the question would be for yourself. And let's say that 3 men say yes, and 15 women say yes. 28 men say no, and 2 women say no, and 4 men say maybe, and 5 women say maybe. Okay. That's the extent of my creativity today. So what the question is, I don't know. You can come up with it yourself. If I'm about to ask you, so can you see? There's a group of people I talk to. Can somebody tell me how many total men did I talk to?
35.
35.
Yeah, where are you looking to get that? This is the men column, right? So there's 35 men that I talked to. So this kind of totaling thing seems to be a good idea, because what are probabilities based on? The total number of people or things, right? So how many women did I talk to? 22, crazy. How many people said yes?
39.
Now here's where things get a little crazy sometimes. Sometimes I'll have somebody put here 104. I like the look I got. There's 57 people, right? And then you can check it here. 48 and 9 is 57. But what that person did was they counted everybody twice. Do you see that? So be real careful. Obviously, this is a check. 57 men and women, so there must be 57 people that said these things. Not suddenly a magic, another 57. They cloned themselves or something freaky. All right, that's another class. It's not pure math. So I can ask you very, very basic questions. Now, let me see what you guys think. What's the probability? If I pick one person, so let me write that down. I'm going to randomly select one person from this group. Spelled correctly, Jeff. There you go, buddy. What is the probability that I pick a woman? I like it. How many chances do I have to pick a woman? 22. Now, what would you tell the person? And everybody understand, that's the correct answer. What would you tell the person that wrote this down? Why do you think they wrote that down? Because that's the biggest mistake I see. The next biggest mistake I see is that. Why do you think they wrote that down?
They're only looking at the women and not the population as a whole.
They're not looking at the population as a whole. They're thinking, I want to pick one woman,
Out of the
and there's 22 women. But that's like saying, there's 22 women in a room, what's probably you pick the one named Frida, right? I mean, that's a different problem. So I really want to make sure that you understand, this is not correct in this case. There's not one chance to get what I'm looking for out of 22 things. No. That doesn't make any sense. There are 22 chances to get a woman out of 57 total things that could happen. I like it. Okay, cool. The wording on that needs work. What'd you learn about today in stats?
How to get a woman?
No, that's not what was happening. So let me ask you a few more questions. Don't say anything out loud. Don't say anything out loud. Try to do this on your own. So I pick one person. Let's probably get a person who said no. Oh, probably you got a man or somebody who said yes. Yeah. Let's see what you guys think here. Who's got the second one here? Probably somebody said no.
30
Yeah, 30 out of... Now let's go ahead and address this issue. You could take this all the way to a percentage. I'm going to ask that you round your decimals to 4 places. Oh, shit. So what is 30 divided by 57 rounded to 4 places?
5263. Or 5263.
0.5663?
5263.
5263. And then what is that as a percentage? Alright. So that's an excellent little place to make sure you remember how to go from decimal to percent. Percentage, of course, what's the percent symbol mean?
Out of 100.
Yeah, per cent. And cent is centime from, or centum from Roman, blah, 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 whatever. So per cent, per 100. So this is this has got division in it. So notice how the percent number is always bigger than the decimal number. Do you guys see that? And for people that really can't remember how to do this, I'll show them. If you write decimal and percent in alphabetical order, if you want to go from a decimal to percent, you move the decimal that way. The other way, you move it the other way. It's crazy. It's all about moving it twice because it's all about multiplying or dividing by 100. I like just a quick little recall about that. This counts as your work, and then you can make it look like whatever you want to. And normally I'll say round it to 4 places. Why do I say that? Because this chart we're going to use, eventually a lot, has all the probabilities out to 4 places. So I just want us to get used to that. What's up? Is it good? What about this one? What's weird about this one? It's not the probability of a woman. It's more specific. A woman who said maybe, yeah. So how many women who said maybes are there?
5.
Good. So this is more specific. What's another way to say this in English? What's the person got to be? They have to be a woman.
Woman that said no.
You went over too quick. There's a really important word. It's got to be a woman. And and said maybe, right? My events need to be better defined here, but said maybe, right? And gets hidden in English. English, of course, is one of the worst, most evil languages on the face of the earth. We don't think so because a lot of us don't think so because we grew up in it. Some of us did not. So you realize how evil it is, right? It's remarkably evil. So, and gets hidden all the time. So woman and said maybe there are 5 people. Notice something about and. I want you to really see this. And is very often called the intersection. So, quick word about and or. And is like the mean bouncer at a club. So you go up to a club and the bouncer says, alright, you gotta know Jim, the bartender. Oh, I know Jim. Hey, Jim. Alright, so also to get in, you have to be rich. Oh, shit. I gotta leave. And you gotta be dressed nice. Oh, shit. I gotta go. Alright, so the and makes less and less and less. So the answer to an and will always be smaller. So woman was 22. So woman and said maybe. It makes sense that it's only 5. It's still going to be out of 57 because I still don't know anything about the person. It could be any of the 57 people. Or is the nice bouncer, right? The nice bouncer says, you got to be rich. Oh, shit. Or you got to be dressed nice. Oh, shit. Or you got to know Jim. I know Jim. Hey, Jim. I'm going to go in. You see what I'm saying? So or always increases the number of things that match. So the probability always comes out higher than it would have been otherwise. Okay, I like it. So what is the probability of getting a man or somebody who said yes?
50.
So how do you get 50?
Because you add the man and the person.
Yeah, 35 men. 18 people said yes, but what's wrong if I do 35 plus 18 out of 57?
You double counted the 3 men.
Oh shit, yeah. So I double counted these people, right? Let me let that sink in. If I count all the men, didn't I already count those 3 people?
Yes.
Let that sink in. So if I count 18 yeses, I'm counting those 3 people twice. Okay, cool. I like it. So one way you can do it is 35 plus 18 minus anyone who's both. So minus the people who are men and they said yes. Or if you can count the situation, there's always an easier way. 35 men plus 15 I didn't count yet that said yes. Either way it's going to come out to be 50, right? So this will be minus 3 if I do it this way. And And of course, 18 minus 3 is the 15 that I hadn't counted yet. You guys see one way or the other? So 50 out of 57. Now watch, if I didn't realize that, if I made a mistake and I forgot to subtract, look what it leads to. So let me give you another one. What's the probability I pick somebody who said no or a woman? So if I didn't realize that, if I didn't realize the thing about double counting, how many no's are there? 30. How many women are there? Oh, that's not going to do what I want. Oh, let's do this. Or a man. That's what I want. So you'll see what I'm trying to do here. I'm trying to make the math come out freaky. How many no's? 30. How many men? 35. 30 plus 35 is 60 freaking 5. So you get a better than 100% chance. More people match what you're looking for than there are people. How the hell did you do that? Right? So if you ever get an answer that's bigger than 1, holy shit, do not accept that. And if you can't see what's wrong, cross through and say, I can't see what's wrong. Because otherwise I'm very conservative. Right? You can't come out with an answer bigger than 1, because that would be bigger than 100%. And that is really freaking me out. It's so going to happen. No, crap. So what did I do wrong here? How many did I count twice? No or men? No or men. I counted 28 freaking people twice. Well, that explains that. So now it should be 37 out of 57, right? And whatever the hell that is as a percentage. Cool. All right, let me stop there for a second. You all look so sad. I'm sorry. You have a rough weekend? It's cold and rainy, which is good. I love living somewhere that I can appreciate when it's like this, because it's so very rarely like this. And you're all looking at me. I love you. You're all looking at me.
If we knew how to drive in this weather, it would be as bad.
Oh my God.
We don't know how to.
Don't even get me started. San Diego snow, man. I don't even want to look at my Google Maps and see how red it is. Okay, let me see if I got you to the point where you can do this. Yes, I do. Ha ha ha. So before I give you this, let's make one formula. So we're going to have several formulas. Let me try. I'm going to say this several times. You're going to be able to write the formulas on your formula sheet, but the formulas will actually be the harder way to do it if you just count what's going on. If I can just count what's going on, I can set up my probabilities. Easy. The formulas sometimes actually get in my way. That doesn't mean that the formulas don't need to exist, because there are situations where I can't count what's going on. I need the formulas, and you'll see those eventually. The one thing I want to do right now real quick is to make a formula for OR. Let me do it based off of this dude down here.
On the test, will we have problems that require us to use this formula?
Oh, hell yeah. Oh, hell yeah. Or said, what was this? Yes. All right, now watch. What's 35 out of 57 in this problem? What was 35 out of 57? Men. What was 18 out of 57? Said yes. And what was 3 out of 57? There was a man, and they said yes. So the probability of A or B will be the probability of A plus the probability of B minus anything that is in both groups, A and B. There's our first little formula. So OR is basically add. That's why it always gets bigger than any probability by itself. I say basically add because you might have to adjust it. There might be some that are in both groups. You have to subtract those people out. If you want a visual, have you ever seen this kind of a visual? We're not going to actually create these on our own. Ever seen this before? Anybody know what it's called? Circles in a box. Venn diagram. All right. Step 1. Get a box. Okay. So if I wanted to do A or B, so I want to count everybody in A everybody in B, oh shit, I counted these people twice. Well, these people are in A and B. So that's the visual of what that formula really stands for. I like it. So you can have that little formula. We're going to make a few more formulas, almost the same way we made this one, by seeing what the hell we did and then putting it into that form. But for right now, I want you should be able to, that's good timing for that, to